Hi students, my name is Arun. So I'll be handling your physics classes for you. So you have been promoted to class 9 and we'll be dealing with the physics chapters. Okay, so we'll be studying the first chapter of physics, that is motion. This year we'll be having 5 chapters. The first chapter is motion. The second chapter is force and laws of motion. The third chapter, gravitation. Fourth chapter, it's work and energy, and fifth chapter, sound. So out of these 5 chapters, everything is having a correlation. Okay, everything is connected. Motion is connected with force and laws of motion. Gravitation is again connected with force, and the energy, work and energy, and sound. Sound is also an energy. So that's also interrelated. So we are having a continuous flow of theory in this 9th chapter. 9 physics chapters. Okay, so today we'll be dealing with our first chapter, that is motion. So we all love to travel, isn't it? We'll be traveling in a car to different tourist places. We daily used to go to school, isn't it? We used to go to market, etc. So what is happening over there? The movement from our house to the school. That movement is called motion. So we all are moving. Even now, when you are sitting in front of the TV or the mobile, you have been moving your head. You are moving your hand. That's a motion. So we'll be dealing with the different types of motion in this chapter. Okay, the different types of motion and how the motion is related with time, etc. will be our point of study in this chapter. Okay, so first of all, motion means it is change in position. Motion means it is change in position. So if you are staying at the position where you are sitting now, you are not moving, you are an idle, isn't it? But when you when you stand from your chair and when you move to the next room, what happens? You are moving, isn't it? So you are moving in such a way that there is a change in position, isn't it? So whenever we are studying motion, what is the important thing which we want to note down is there should be a reference point. There should be a reference point. Okay, so with respect to the reference point, we will be moving, isn't it? With respect to the reference point, if our position is changed, we say a motion has taken place. I think it's clear. Okay, so the motion means it is change in position of a body. Change in position of a body. And how it is changing? The change is being recognized with respect to the reference point. Okay, so we have to what? So the change in position and reference points are the main 2 points which we want to note down during whenever we are studying motion. Okay. Now we are having some other terms like distance. Distance is the important term when we deal with motion. Distance, and a new term, displacement. You might have heard this word displacement and distance. So, is there a connection between this distance and displacement? There should be. Actually, distance is what will help us to understand the change in position. Okay, whenever you are sitting there, I told you in the beginning, you are sitting in the bench or in the table or on the chair, you will be standing and you will be moving to the next room, isn't it? So whenever you are moving, there is a change in position, and that position change is calculated by the distance moved. There is a difference in distance from the chair, the position of the chair, and to the position of the next room or wherever you are, the next reference point. From the initial reference point to the final reference point, there is a change in position or there is a distance moved. So the body is changing or moving or traveling a distance. The distance traveled will help us to understand the motion, the motion. Okay, so that is about distance. And what is displacement? Yeah, I'll explain it with an example. So what is displacement? So displacement, let's consider a track, means the running race takes place in tracks, isn't it? So usually in Olympics and all, we will see a track. Like the track will be of 400 meters. Or the original official length of a track is 400 meters. So 1 lap is equal to 400 meters. So when this is the starting point, the race starts. Usain Bolt starts from here. Usain Bolt will start from here. He will be running. Whenever he starts running through the track and when he reaches the end point, that means the starting point, and same the starting point is the ending point also. Okay, so whenever a runner starts from here, he covers the whole track, and when he reaches the ending point, he will be covering 400 meters. That means the distance covered will be 400 meters. The distance covered will be 400 meters. So now I will be explaining what is displacement. So what is displacement? Displacement is the shortest distance between the initial point and the final point. The shortest distance between the initial reference point and the final reference point. Clear? Okay, so here, which is the initial point? This one is the initial point, the starting point of the track. Now, which is the final point? The final point is again here itself. That means the initial point and the final point is same. Okay, so the initial point and final point is same. So what is the difference between the initial point and the final point? The starting point and the ending point. What is the difference between the distance between the starting point and the ending point? That means there is no difference. So the displacement is 0. The displacement is 0. I hope it's clear. So displacement means what? The shortest distance between the initial point and the final point. For example, another motion. A body, whatever body it is, this is the starting point, and that body is moving in a zigzag position, and it reaches here. This is the ending point. Okay, so the body is moving in this way, and it reaches at this point. So the total distance travelled by the body, we have to calculate the whole distance which it travels like this. But what is displacement? The shortest distance, that means the perpendicular line between the starting point and the ending point. So if we draw a perpendicular line, this will be the shortest distance between the starting point and the ending point, isn't it? So this is the displacement. This is the displacement, and the whole distance will be travelled. The whole way length it travels is the distance. Clear? Between the initial point and the ending point. Okay, so I hope it's clear. What is distance? What is displacement? It's clear to you. Clear. Now, one more thing which we want to note down when we are discussing displacement and distance. Distance will only help us to find out the magnitude. Magnitude means how much distance it travelled. Okay, how much distance it travelled, that will be only explained by distance. Distance will only explain how much distance a body travels, but it won't explain anything about direction. Okay, in which direction it travelled, it won't be explained by distance. Distance will only help us to find out what is the magnitude of the body traveling. Okay, the magnitude of the distance the body travels will only be explained by the distance, the quantity distance. So we will say the distance is a scalar quantity. We will say the distance is a scalar quantity. That means it will only explain the magnitude, but the displacement, it will explain the direction, in which direction it moves. So the displacement will be explaining the direction of motion also, as well as magnitude. The direction of motion as well as magnitude. So we can say that the displacement is a vector quantity. You will be studying these terms in your higher classes. So just note down that the quantity or the term which explains only magnitude is scalar quantity, which explains both direction and magnitude, it is vector quantity. So the difference between distance and displacement is clear to you. So now we are moving on to the next new terms, that is speed. Okay, so the equation for speed etc. you have been studying in your lower classes. What is speed? So just recall the points. Speed is equal to distance travelled by time taken, isn't it? Speed is the distance travelled by time taken. Okay, so I have told you in the beginning, in this chapter we will be studying the relationship of a body, moving body with the time. Okay, so we have to deal with these terms also. What is speed? So speed is the distance travelled by time taken, isn't it? So the distance travelled is enabling us or helping us to find out that a motion has taken place. Okay, and this distance travelled, when it is related with time, we will get a new term, speed. Okay, and also we have studied another term, that is velocity. So what is the difference between speed and velocity? You may think that both are the same. Okay, you may think that speed and velocity are the same, but there is a slight difference. I have told you before that there is displacement, and distance, isn't it? So distance, I have told you, this will only deal with the magnitude or the quantity, how much quantity of distance has moved. But displacement, it will deal with quantity as well as the direction. So velocity is equal to displacement by time. Velocity is displacement by time, but speed is distance travelled by time taken. Okay, it's clear. So velocity will be dealing with magnitude as well as direction. Velocity will be dealing with magnitude as well as direction because it is displacement. But speed, we will only consider the magnitude term or the quantity, how much quantity the distance has travelled or the body has travelled. Is it clear? So this is the difference between. So now onwards, don't think that the speed and velocity are the same. No, speed and velocity have a slight difference, and that difference will be here where the distance travelled. It can be having both magnitude and direction, then it is velocity. If we are considering only the magnitude, then it is speed. Okay, so that is clear. Now you also know what is the SI unit of these two terms. SI unit means what? The standard unit. We will be measuring length in meters, we will be measuring time in seconds. So here displacement or distance, the basic unit, the SI unit is meter. The SI unit is meter, and divided by time is taken. So the SI unit of time is second. So what will be the SI unit of speed or SI unit of velocity? Both are distance. This is also length, this is also length. Distance and displacement both are length. And time, what is time? Time is measured in seconds. So meter divided by seconds, this is the SI unit, and we will be denoting it by meter per second. So the speed or the velocity is having the SI unit meter per second. I hope it's clear. Okay, so now we have to understand a new term, not a new term, you have to understand the different types of motion. Okay, so basically we have two types: uniform motion and non-uniform motion. Uniform motion and non-uniform motion. So what is uniform motion? What is non-uniform motion? So uniform motion means whenever a body is traveling equal distance in equal interval of time. equal distance in equal interval of time. That means the speed is same. So we know speed is equal to distance by time. So whenever a car is moving from rest, for the first 5 seconds the car moves 10 meters. Then after the 5th second till the 10th second, so the next 5 seconds also, if it moves 10 meters, we will say that the body is in uniform motion. That means the speed is constant. Okay, and if the body is not moving in uniform motion, that means if it is not traveling equal distance in equal interval of time, then what we can say? The body is in non-uniform motion. Clear? Okay, for example, so what is uniform motion? Equal distance in equal interval of time, equal distance in equal interval of time, non-uniform, in equal interval of time, in equal interval of time, non-equal distance. Okay, so this is uniform motion and non-uniform motion. For example, if we consider a body, if we consider two cars A and B, okay, so let us take time. The first car, distance travelled by first car, distance travelled by car B. Okay, so two cars are starting at 9:30 a.m. They were placed, two people were going to work. Okay, they are moving to their workplace in their cars. Okay, so the first person is moving in car A, second person is moving in car B. If the first car starts at 10 a.m., 9:30, and at 9:30 it is at 0 meter, this is also at 0 meter, it is from rest, it is starting from rest, so it doesn't travel any distance, so it is at rest. At 9:45 a.m., after 15 minutes of travel, car A travels 10 meters. Clear? But car B, it travelled 6 meters. Okay. Now at 10 o'clock, so the next 15 minutes, after the next 15 minutes, next time interval, it reached 20 meters. So from 10 meters it again moved another 10 meters. The difference is 10 meters. Isn't it? Okay. Now, but here what happened is it moved 13 meters. But so here it was 6, but here again it is 7 meters. The difference is 7 meters. So it is not traveling equal distance in equal interval of time. Now at 10:15, what is happening? It will travel 30 meters. So again the difference between 10 and 20 and 30 is again 10 meters. But here it reached 22 meters. Okay, 22 meters. So the difference is not equal. Okay, so what is the difference between this one? 9 meters. So again 6, 7, 9, it's not equal. The distance is not equal. But here the body is moving equal distance in equal interval of time. So this motion of car A can be said as uniform motion. The motion of car B can be said as non-uniform motion. Okay, so that's also clear. So keep in mind the terms. What is distance travelled by a body? If it is travelling equal distance in equal interval of time, that is said as uniform motion. If the body is travelling non-equal distance or unequal distance in equal interval of time, then we have to say that it is non-uniform motion. Clear? Okay.